C was n squared, because 1 squared is 1, 2 squared is 4, 3 squared is 9. Most of you should have gotten that one. The next one, they said, okay, if you really look at those,
n plus 1 over something.
N plus 1 over 2n minus 1.
I don't know.
Actually, I mean, not 2
These are going up by 1, but these are going up by 2.
That one. Yeah. It's n plus 1.
All right, if we have n plus 1 over 2n minus 1. Okay, let's try it out. If we put 1 in there, we get 1 plus 1 is 2. 2 times 1 is 2. Minus 1 is 1. Okay. 2 plus 1 is 3. 2 times 2 is 4. 4 minus 1 is 3. This seems to work. Okay? Now, let's go on to the next page and see what's happening. All right. What does this say? This says, if a sequence has a finite limit as n goes to infinity, we say the sequence converges. If a sequence does not have a limit, finite limit as n goes to infinity, then it diverges. Determine whether the following sequence converges or diverges. So I guess we have to take a limit to infinity, right?
Yeah.
All right, so what did you all decide on this one? Okay. Why? That's what I'm asking, guys. I'm asking.
It gets further away from 0.
Well, look at this. If I do a limit as n goes toward infinity, how would you do this? Well, L'Hopital is one way. Another way is to say the degree of the top and the degree of the bottom are the same. Therefore, the limit is 1. So if this goes to a finite something, we say converge. Thank you so much.
Oh.
Yay, team. You understand that? Good.
I get that. Say more. I get that.
Okay, good. Okay, now. All right, how about the next one? What's the deal on it? All right, if I have, so what are you telling me?
Converges on 0.
Okay, this limit as n goes to infinity of 1 over 2 to the n is equal to 0, so we're saying converges. Yes? Okay.
So can you just use like the rules that you know?
Yeah. So far for these, yes. All right, what about this thing? See, I'm thinking diverges, because doesn't this thing go back and forth and back and forth and back and forth?
Yeah.
Okay, so I'm thinking diverges here. All right, how about this thing? Wouldn't this be 1 over negative 2? So this is converges. Okay, how about the natural log of n over n? Okay, now let's think about that for a minute. What is ln of a big number? Okay, so I have infinity over infinity, don't I? So couldn't I use L'Hopital?
Yes.
Okay, limit as n goes to infinity of ln of n over n. So I get 1, all right, so I get infinity over infinity. So I apply L'Hopital, and I get the limit as n goes to infinity of 1 over n over 1. And now what do I get? 0, so this converges. Okay, folks, I was talking to Mindy yesterday during 6th hour about these. Now, you have to know what they mean, or this doesn't make any sense. Okay, so some of you might have seen this maybe once in your life when somebody taught you it quick before an ACT test. Okay, so we have n times n minus 1 times n minus 2 times n minus 3, etc. Okay, this one is n plus 2 times n plus 1 times n minus 1 times n minus 2 times n minus 3, etc. Okay, that's what happens. Because, like if I have 5 factorial over 10 factorial, we have 5 times 4 times 3 times 2 times 1 over 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. This and this go away. Okay, so that's the deal. All right, now, so what do we have here?
1 over
We have basically the limit as n goes to infinity of 1 over n plus 2 times n plus 1. So what do we get? 0. So this converges. Okay, now, this next one, limit as n goes to infinity, n times n minus 1 times n minus 2, etc. On the bottom, I have n minus 1 times n minus 2, etc. So what do we wind up with? N. So what does this thing go to? Infinity. So we have diverges. Okay? Does that make sense? Marvin, Ethan, people in that row I can't see. Yes, makes sense or no? Okay. All right, so then you should be able to do the little homework page that went with this. All right, now let's look at this next one, which is series. Oh boy.
Oh boy. So about when are we gonna be done, like, learning? So this is just repetitive after spring break?
Hopefully not, but it might be. I mean, we have a lot more to do. I mean, this is
For a month and a half. Are you so, I mean, I'm just saying, you're gonna have like we review for a month.
don't you want to? We can
Well, yeah.
review for that.
We're gonna make your series for
See, I'm thinking we start over and we just go through everything. I try to do series last so it sticks with you the most. Because this they definitely ask. This is a definite. There's no let's talk about it, let's maybe think about it. It's on there.
Yeah, we will work it.
Will they ask about the AP test, not like the first 2 lessons you did?
Yeah, but that's a quarterly test.
Oh, with the series and sequence, no. But I'm just trying to get
Did I
to
get that?
what is what.
Is that what you're looking at?
Yes. What is a series? What is a sequence? I mean, how many times did they go over that now for 2?
Once.
I mean, yeah, I mean, that's it. And because you guys didn't have pre-calc, see, some kids in other schools have a whole class of pre-calc. So, but even in there, you only go through it like, you know, so they're thinking it's a little more important than that.
Series?
Okay, series on a graphing calculator. Let's do parametric mode, or do you want to do sequence and do it on the 89?
Yeah.
You want to try this one? Because parametric mode we did yesterday, so let's do the 89 today so that people with the 89 know what's going on. I'm not sure I've ever done this on an 89. I think I always use the other one. All right, sequence mode. Okay, we got to go to sequence mode.
Where?
I am on mode. I press the MODE key, which is below alpha. Okay, and then I went down to sequence, and I'm going to hit enter twice, 1, 2. So now, if you look on the bottom, I am in SEQ, sequence mode.
It entered twice.
Yeah, you gotta hit enter twice or it doesn't change it. Then, press Y equals. I can do it. Second F1. No, that's not it. No, I can't do it. Diamond F1. See, I don't use this very often. You see the little U ones there, Brandon? This is what you asked about yesterday. There's the U's.
Yeah, no, I didn't know what they meant.
I'm with you.
Okay, now it says, let U1 equal sum. Okay, you can get the sum by doing math.
Second. What?
Second 5, math. And we want to go to A, it says. No, we want to go to B, don't we?
Yes.
B,
Where are we going?
and we're going to 4. Okay, one more time.
Second
What do you
5.
mean by scroll down?
Second 5. Second 5. You're in
Oh.
math, and you go down to calculus. Is everybody down to calculus? And then, which is not, on here it says calculus is A, calculus is not A, it's B, because we must have the newer version of the calculator. But, and we want to use summation. So that's number, what was it, 4? 4. Okay, now, we want, what? 1 divided by, where is n?
6.
Alpha 6.
We have to use that.
Comma, alpha 6, comma 1, comma, alpha 6, parentheses. Now, what are we trying to do? Why don't we read the top first, find out what we're trying to do here. You may graph the sequence of a partial sums for an infinite series by using parametric mode or using sequence mode. Okay, so we are wanting to look at this series 1 over n, I think is what we're trying to do. All right, now, it says we need to go to the window. Once we type this in, you hit window. Second F2, window. N min, 1. M max, 20. Plot start, 1. Plot step, 1. The x's, -1 to 20, and the y's are -1 to 20. Girls over there, good, bad, yes, no? Kendall, Sarah? Yes? All right, so now I should hit graph, I guess, and see, ooh,
Should we take it out?
it says, it should automatically do dots. Now, let's trace. I want to see what it says when I trace it. Okay, but
What is yours like?
think about what it's doing. Think about what this is doing. If you put 1 in, you get 1 over 1 or what? I put in 1, I get 1 over 1. I put in 2, I get 1 over 2. I put in 3, I get 1 over 3. But look what the calculator's doing when you trace. When you were at 1, it's what? When you move to the right, you get 1.5. What is 1 plus a half? 1.5. Okay, now if I move again, I get 1.833 because it added 1, a half, and a third. It's giving me the y values. It's giving me the sum.
How do you
Okay,
trace
one more time. I just explained exactly what it's doing. And this is my x's. I am at 1. The value it returns is the sum. If I only had 1 over n, and I put in a 1, I get 1. If I put in a 2, I get a half. But when I trace along here, my y value says 1.5. Why? Because it added the first term and the second term. So 1 plus a half is 1.5. Okay, so when I went over here, I get 1.5. If I go to the third term, it's added 1/3 to 1.5. So if you add 0.33333 to 1.5, what do you get? 1.833. That's what you're seeing on your watts, okay? You're seeing your partial sum on your watts. What? Let us see. Oh.
But it stinks.
That's because you got salt nuts. Oh, no. Did you go to sleep this morning? No, you didn't bother to find some correctly. Here, you didn't. You couldn't have because it's not working. Okay, so we're going to go to second 5 math. We're going down, no, go down to B, calculus. Go to number 4, sum. Please. Okay. It should automatically put it.
Yes, it's in a sequence, but it's not.
Okay, now, let's go to, all right, look at the next thing they want us to do on this. I'm like, what? Okay, you're in sequence. It won't go. Style, let's just hit style, F6. Go to dot, be a brat. The calculator.
Sign it, Jacob.
Here. I made it, I changed the style. I don't know why. I don't know. Okay, so we did that. Okay, let's go to page 2 and see what they want me to do. What does it mean for a series to converge to diverge? Let's look at a couple of geometric series. Given this series,
It's going to 0.
okay. Given the series 3 over 2 to the n, 3 halves, 3 fourths, 3 eighths, 3 sixteenths, blah, blah, blah. Find the first 10 terms of the sequence of partial sums and list them below. To do this on the 89, you can just add the numbers as you can use the summation command found under F3 or in the catalog, or we just found it, right? The last number in the command requests the number of terms you are adding. All right. So, if we wanted to get the 10th term, couldn't we just type in on the home screen, I am going to type in, I'm going to go backwards, and we're going to say 3 divided by, parentheses, 2 raised to the n, which is alpha 6, parentheses, comma, alpha 6, comma, 1, comma, what do we want, 10 of them?
10.
Okay. Okay, so we get that it is 3069 over 1024, which, if you wanted a decimal, this,
Yeah.
I get 2.9970703. How do I go where? Okay, now. It said up here, find the first 10.
Okay, I got it.
Okay.
Wait, it's like,
Oh, God.
All right, now. So what do you notice about the results? Well, why don't we do this? If we want to see what's really going on, why don't we go and see what would it do if I asked for 15 terms?
It gives you a bigger. I'm big on that one. Still almost 3.
Okay, so it seems to me like it keeps getting closer and closer to 3, right?
Right.
Okay, so, and you could experiment by putting different things in there and seeing what's going on. Now, yes, sorry. Yes, there is. All right, now, what do you notice about the results? What does the formula for the sum of an infinite geometric series, S equals A sub 1 over 1 minus R if R is less than 0, where A sub 1 is the first term and R is the common ratio. What is the common ratio between these?
Negative.
1/2. So S equals, my first term was 3/2 divided by 1 minus 1/2. And this is equal to what? 3/2 divided by 1/2, which is 3. Because our common ratio was 1/2, wasn't it? And when R is less than 1, what can we do? We can use this summation formula. All right, now, what's different about this one than that one?
The whole thing is to a power.
Right, the whole thing this time is to the power, so that means what's R this time? 3/2. So that means R is greater than 1, so that means this diverges. Because it's going to get bigger and bigger and bigger and bigger and bigger, right?
Yep.
Okay, now, believe it or not, you have enough information to do the 2 little packets, the 2 little worksheets I gave you. If magically it ices on Sunday,
Finally, I'll have to take it for
It's so big.
on the channel you looked at, okay, now, if it should ice, you have plenty to do. Do not come in and tell me that you need more time for stuff, because if we magically get a day off, you better use it wisely. I gave you one today. I gave you one yesterday, and I gave you one today. Did you break your calculator?